Today we're going to talk about Newton's second law of motion. Please make sure you have your notes in front of you and that you're ready to take them. By the end of this video, you should understand what Newton's second law of motion says. You also should be able to understand how to use the force equation to be able to determine force, mass, and acceleration. You should also understand that weight is a force and how to calculate weight. First, let's define Newton's second law of motion. Newton's second law of motion says the net force of an object is equal to the product, which means multiplication, of its mass and acceleration, or F equals ma, for force equals mass times acceleration. We can rewrite this equation F equals ma, and we can solve for mass, which would be F divided by a. We can also solve for acceleration, which would be F divided by m. So what is a force? A force is a push or a pull that causes a change in the motion of an object. So what are some examples of forces? Well, first we have frictional force. That's the force of friction. Then we have normal force. Normal force is the force that pushes back on objects to keep them from being pulled to the center of the earth. Then we have gravitational force, which is the force that pulls all objects down to earth. And then we have applied force. That's like a push or a pull. So what is the unit for force? Well, 1 Newton is the unit for force, and that is the force that is required to accelerate 1 kilogram of mass at 1 meter per second squared, or a kilogram times the unit for acceleration. That is equal to a Newton, and Newton is what we use for force. Also, as a reminder, acceleration includes velocity. Velocity is a vector quantity. Acceleration is also a vector quantity, which means that force is also a vector quantity, which means anytime we use force or discuss force, we must include a direction. So let's look at this example. This says how much force is needed to accelerate a 1,400 kilogram car 2 meters per second. So first, I'm going to fill in the information I don't know. I know that 1,400 kilograms goes with my mass. I know that my acceleration is 2 meters per second squared. Now I'm going to write my equation, which is F equals ma, and the force equals 1,400 kilograms times 2 meters per second squared. That means my force here is 2,800, and remember my unit is newtons. Now, on the previous slide, I said that we needed to include direction. This problem does not give us a direction, so I'm going to assume that the car is moving down the road. So I'm going to add the direction down the road. And that is how I would calculate how much force is needed to accelerate that car. Let's look at this table together that relates force, mass, and acceleration. From here to here, we can see our force doubles, but our mass stays the same. In order for that to occur, our acceleration must also double. But from here to here, notice that our net force doubles, but our acceleration stays the same. Since our acceleration is staying the same, our mass must double, which means that in this instance, our mass must be 4. Here, if I'm trying to find what my net force is here, 1 kilogram times 10 meters per second is 10 newtons. If I'm trying to find how much acceleration is in this object, if I have my net force of 10 and my mass is 5, then that means my acceleration is 2. So, as a takeaway from that table, if mass remains constant, if we double the acceleration, that also doubles the force. And if the force remains constant, doubling the mass reduces the acceleration by half, because there is a relationship here between force, mass, and acceleration. It's important to know that weight is also a force. Weight is just the force of gravity. And so weight is a play on the equation of F equals ma. In this situation, RA is the acceleration due to gravity, but we specifically define it since we know what gravity is. Our mass is the mass of the object, and weight is a force. Because weight is a force, you should know that the unit is newtons. And when we are talking about acceleration and weight, the direction is always down because gravity is pulling us down to Earth. So this equation of W equals mg explains why different masses accelerate to Earth at the same rate but with different forces because their acceleration is the same. It's always 9.8 meters per second squared down, but they impact with different forces because they have different masses. So let's look at this example together. This example compares a 10 kilogram object with a 1 kilogram object. Here, we're trying to find the acceleration on Earth. So we do 98 newtons divided by 10 kilograms. When we do that, we get 9.8 meters per second squared down, and we know that that's the acceleration due to gravity. Let's also look here. Here, I'm also finding the acceleration. My force is 9.8 newtons. I divide that by 1 kilogram, and I still get my acceleration is the same. Gravity on Earth is the same no matter where you go. You have to leave Earth's orbit in order to have a different gravity acting on your body. So, now that we've discussed Newton's second law of motion, you should understand what Newton's second law of motion says, how it applies to life, and how you can mathematically find force, mass, and acceleration. You should also understand that weight is a force and understand how to calculate weight.